So the two things that we're addressing today are how does carbon dioxide make the water more acidic when it doesn't have a hydrogen? Because we've talked about the fact that the pH is affected by hydrogens. And we even like showed equations. The one equation that I have showed you is this one, which you're going to recognize. We talked about hydrochloric acid, which is a strong acid. And we talked about how it dissociates, right? We talked about dissociation versus dissolving. We talked about hydrochloric acid dissociating into H plus chlorine. And we talked about how it is the hydrogen ions that lowers the pH, right? So we talked about this. But there's no hydrogen ions in carbon dioxide. So when we keep talking about the carbon dioxide in the atmosphere and climate change, which increasing carbon dioxide, how is it that increasing carbon dioxide in the atmosphere has any effect on the acidity in the ocean? There's no hydrogen in it. So we're going to talk about this today, all right, just briefly. So although, I'm going to read and explain as I go. So although we often experience carbon dioxide dissolved in liquid water when we drink carbonated beverages like soda or sparkling water, carbon dioxide can also react with water to form a compound called carbonic acid. So there's the acid. Now, when we drink sodas, we experience carbon dioxide as bubbles, right? And when we blew into the water, all these bubbles came up. So the carbon dioxide isn't staying in there. It's not like when we blow into water, it disappears and reacts with the water, or when we drink soda, oh, wow, where'd the carbon dioxide go? No, we know where it went. It went into bubbles, right? So it didn't react. Well, this reaction only occurs when carbon dioxide molecules collide with water molecules in the correct orientation. So they have to like align. Nope, 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 nope. Oh yeah, there it is. They have to align perfectly, the correct orientation with exactly the right amount of energy. So it's a very not likely reaction to occur. So lots and lots and lots of molecules of carbon dioxide come into water, but only a small amount of the carbon dioxide ends up forming the carbonic acid. So in the first place, you're bubbling carbon dioxide into the water and only a few molecules are turning into this acid, okay? And the rest just bubbles out. The majority of it just bubbles out, but only a little bit of it turns into the acid. So that's the first step. That's the first thing that we need to talk about, okay? Is that only a small amount of the carbon dioxide, only a small amount of the carbon dioxide actually gets converted into carbonic acid. Imagine if all of those molecules got converted into carbonic acid, there would be this tremendous dip in the pH immediately, right? But there isn't. It's a very slow process. Very, very slow process of this pH dropping. And, by the way, it's a very slow process of carbon dioxide increase, too. You know, climate change isn't happening like overnight. Well, I mean, I guess geologic time it is. But in your lifetime, in my lifetime, not happening overnight. It's happening slowly. So between these incredibly slow processes, no one's believing it's happening. See that? You see? Nobody's saying like, oh my God, this is terrible. The temperature just went up 5 degrees last year. We have to stop that. No, everybody's going like, yeah, the ocean temperature went up 0.2 in the last 20 years. Do we really have to worry about this? Right? Because it's happening very slowly in carbon dioxide, and it's happening very slowly in pH. So between the two of them, this is happening really slowly. But like over 50 years, this is happening kind of quickly. You get my point? Okay. So chemists model the formation of carbonic acid like this. And this is on your paper. What kind of a reaction is this? We learned the 5 types. Which type is this one? Does anybody know? Eliza? Synthesis. This is a synthesis reaction. Oh, sorry, hang on. My pencil tip just died. Oh, okay. This is a synthesis reaction. Only one product. Okay? It's a synthesis reaction.